All right, action. Here we go. So we left off with our enzyme cut sites, and we determined that this was not the one that we needed. Thank you. Okay, awesome. And so we'll leave that up, and we're going to get rid of PBS SK just so it doesn't distract. So now we're going to do this cut site here and figure out where these are. So ZO1 is at 740, EcoWar1 is at 707, and then SCA1 is way over 2562. So let me just do a quick little screen capture for us to make life. Nope, that's useless. Hold on a sec. Whoop. We don't need that. Delete. Okay, so we've got some cut sites. We got one here. We got there. And then SCA1's over here. All right, so ZO1, EcoWar1, and SCA1. Okay, so now we got to figure out our fragment lengths, right? So we've got several different lengths that are important to us. Let's see here. So 740, 707. And 2526. Okay, so now what you need to do is actually figure out your total fragment lengths for each. So you want to figure out that fragment. So now keep in mind that when, hold on a sec, let me get a different color. Okay, those are fun. Okay, so you want to figure out this piece here. This little chunk here is going to be removed because that's where we're going to splice our gene into. And then stars? Happy faces? Okay. Okay, so we need to figure out each fragment length, and using those fragment lengths is what we're going to use to actually piece the entire thing together in our recombinant map. Okay, so our grand total was 3283, so that's a little bit bigger than 2961. So when I draw my recombinant map, so let's just say there is where we'll put our 5' enzyme, and then the other one was just past half, so we'll go there. And then we got a SCA1 site sort of halfway there. Well, let's just wait. Yeah, it's just past half there. Okay, so there's a SCA1 site about there, and I'm just being approximate here. Okay, and then this one was closer to which? So one EcoWar, one about halfway across. Okay, so on my map, I've got my first enzyme, ZO1. Got my second enzyme, EcoWar1. Nope, sorry, that's SCA1. EcoWar1 is over here. And then the SCA1 over here. So you notice that the fingerprint enzyme is going to cut within the plasmid as well as the vector. So if we look at, or so the plasmid as well as the gene. So our gene of interest starts from here and goes over here. That's horrible. Let's try that again. All right. It's hard to do with the mouse. It's easier to do with the marker. All right, stay in the lines. Thank you. Okay. And so that's our gene of interest. For me, it's SMAD4. And then our P blue script vector is here. So that's my recombinant. All right. But what you want to make sure that you do is get your numbering right. That's critical. Okay. And I'm going to leave that for you guys to figure out how to do. But you have to keep the numbering consistent with the numbering system that was in PBlueScript in the first place. Okay, and we've done this before in class. I've shown you this method before. Yes?
How did we know to put a scattered one in G2?
Like in here?
No, in that one.
In this one here. Oh, well, that's our fingerprint enzyme. Remember, we located it at 2154, and then we located it here at 2526. Okay? And so that's how we know that. Okay? And there you go. So now once you've got your recombinant, you're going to actually write the name of this thing. So for me, mine would be called P. Hold on a sec. Let's do a bigger one. Mine's going to be called PBS KS, because that's the one that I used, SMAD4. So that's the name of my plasmid. And sometimes you don't even name the entire vector, but for us, we're going to, okay? Because that was actually an important thing, okay? And the next thing you want to do is actually figure out what your total fragment length is. So, you know, number. It's going to be certain number of 1,000 base pairs, BPs, for your total, okay? So the other thing you have to do is actually put your values here. What are the map locations at each enzyme site? And again, I'm going to leave that one for you guys to figure out how to do. That's part of the problem-solving process. Okay. Okay, let's move that guy over a bit. So whatever those location numbers are, and then you want to actually write in your fragment lengths, right? So for example, if I go back here, this one here is going to be the 1922. So I'm going to actually write, this is going to be horrible, I'll forewarn you. 1, hey, maybe not that bad, 9, it's like in kindergarten again, 2, right? So that's my 1922 fragment, and then the other one over here was 1361, 1, 3, 6, 1. And the reason you're going to write these fragment lengths between the cut sites is to give you a clearer ability to add and subtract when you do your digestions, okay? Because there's diagnostic digestion that you have to do at the very end of this all to prove that you would have your plasmid, that this gene actually did incorporate and connect up with that gene, okay? Hey, that's kind of cool. The colors overlap, so that's like their sticky ends overlapping, right? Okay, so then of course you need to put your numbers, whatever they would be in here. Okay. This actually really isn't hashtag. That's a made-up thing from Twitter. This is just the number sign, right? So whatever the value is for that fragment in there, whatever the value is for that fragment in there, and you'll have to figure this out yourselves. Okay, I've already kind of shown you how to do the first one. And that's that, right? So then the next piece of it is to do your custom digests, right? And then you're going to provide a proof for the location of the start and stop codon using amino acid sequences. Okay, so this is a whole nother thing. I'll queue up a different video for that. So this is for mapping and